Assalamualaikum and a very good morning to Dr. Jamila and fellow students. In this presentation, we would like to discuss on Eco Calculator, Sustainable Tracker for SDG 12. Our group, Pizza Grammars, which consists of me, Rauda,
I'm Shavina.
I'm Nur Aisha.
And I'm Jayadanya.
will walk you through the whole journey. Sustainable Development Goal 12 focuses on responsible production and consumption, which is a critical global challenge. Our project aims to engage students by developing a calculator that measures their environmental efforts, encouraging sustainable behaviors within our academic community.
Problems and challenges in responsible consumption and production. The environment is harmed by unsustainable consumption and production practice worldwide, leading to greater social inequality and destabilization of the economy. SDG 12 emphasized the critical need for the effective waste reduction, energy conservation, and sustainable resource management. Our project introduced an eco-calculator using object-oriented programming to track users' recycling and energy consumption, empowering users with measurable environmental impact scores and fostering a sustainability culture. It scores recyclable materials and energy use, offering ranking and feedback to sustain engagement. Our project objective is to ensure the project is success by engaging the students in SDG 12, promoting sustainable habits, providing environmental insights, cultivating environmental responsibility within the Faculty of Computing, and advancing responsible consumption and production practices aligned with the SDG 12 scope of the project. Additionally, our initiative is to introduce a user-friendly calculator using C++ and object-oriented programming designed for the students and also the staff of Faculty of Computing. It tracks weekly recyclables such as glass, paper, plastic, and monthly energy used via a CLI interface. It calculates the environmental impact scores and fostering a culture of sustainability. This tool aims to educate and motivate users, encouraging them to adopt greener practices while contributing to SDG 12 objective.
Now let's take a look at the UML diagram of our system. This diagram illustrates the structural relationship and interaction between key classes. Firstly, we have base class recyclable item, which serve as the blueprint for managing various recyclable materials. Derived classes, such as glass, paper, and plastic inherit from recyclable item. This inheritance hierarchy allows each material type to implement specific method like add wave, get wave, and calculate score according to its unique properties. Glass, paper, and plastic items are differentiated by their wave and scoring mechanism. In the diagram, association depicts how weekly streak aggregates instead of recyclable item during each tracking period. This dynamic association allows the system collect data on a recyclable item without implying ownership. Polymorphism allows the system to handle different types of recyclable item consistently, which is crucial for calculating total recycling scores over time.
So now moving on to the system design overview, we have 5 different classes, which is recyclable items, which is then derived into 3 classes, which is glass, paper, and plastic. And then we have user ID class for user identification, energy consumption class to handle energy usage, eco class to calculate contribution scores, and weekly tracking streak class to track recycling efforts. Then I will show the coding now. So in this coding, we'll start off with all the libraries, and then we have our first class, which is recyclable item, and we have all this add weight, get weight, and calculate score. So this is where we've set the value for glass, paper, and plastic score, which is for glass it's 3, for paper it's 2, and for plastic it's 5. And then we have the user ID class where we will get the user ID and the avatar. And then we have the energy consumption class where we get the electric bill and water bill, and we've set the electric bill according to the certain value of the electric bill. So we've set the score. So if it's more than 100, then it's 0.50. If it's more than 50, it's 0.25. And if it's equals to or lesser than 50 bits, then it's just 0. And then same for the water bill, we have if it's more than 30, then the score is 0. It's times 0.55. If it's equals to 0 or less than 30, then it's times 0. And then we get the energy consumption total by adding the electric bill and the water bill. And then we in the class we calculate the contribution score by using the recycling score minus energy consumption. Then after that we get the ranking by their contribution score. So if the contribution score is equals to or more than 100, then we'll display excellent job and the whole message. If it's more than or equals to 20, then we display good effort, there's room for improvement. If it's lesser than that, then it needs improvement. Let's step up your game. And then we move to the next one, which is class weekly tracking streak, where we have vector recyclable items in streak and weeks count. And then we'll add the weekly item. We'll calculate the total recycling score, and we'll evaluate the streak and by checking if they have input in that streak or not. If they don't input anything in that streak, then their weekly streak and week count will not rise. And then we get streak, we get week counts, and then we have a destructor for this class. And then we'll display the intro message, which is welcome to Sustainability Tracker, track your recycling and energy usage and make progress in SDG 12. And then we'll also display achievements based on their progress, which is like congratulations, you've completed this number of weeks of tracking, and also achievement unlock consistency is key. Then we also display weekly tips, which is at random. So any random few weeks, they will display one of these tips. And then in the in main, we'll get the user ID, get the avatar such as Eco Warrior, Green Guardian. And then we have bring back all these classes: user ID, weekly tracking slate, Eco Cult, energy consumption. And then we also check while true, the input count will be 1 and input count will be lesser than or equals to 2, because like I said earlier, we are only getting 2 inputs for each week. So that's why we've set lesser than or equals to 2 for the input count. So we'll get all their input of number of kilograms of glass, paper and plastic. And then we'll also we'll set this up to all the functions from the recyclable item and also the weekly streak by adding the glass item, paper item, and plastic item. And then we'll also we will first evaluate the streak and then also increase the week. And then we also calculate the electric bill by checking every 4 weeks. This is because we assume that every 4 weeks they've completed 1 month, so they have the electric bill and water bill. So that's when we ask for the electric bill and water bill. And then we calculate the energy consumption, and we calculate the recycle score and energy consumption, and then we take the contribution score from calculate contribution score, and then we display all of that and also get the ranking and also display the achievements. And then we also after all this, that is the main program. After all of that, we'll ask for their response if they want to continue the next week. If they say yes, then we'll continue. If they say no, we will show our end message. If they respond either none of that, then we'll display error message to respond either yes or no. So the end message will be thank you for using Sustainability Tracker. Keep up the great work in promoting sustainability. So our whole program encapsulates association, aggregation, inheritance, composition, and also polymorphism. So the inheritance can be seen in the recyclable item to glass, paper, and plastic class. And then aggregation is shown in weekly tracking stick, where it handles a group of recyclable items for each tracking period. This aggregation does not only imply ownership, instead it also allows the system to handle multiple items efficiently. Composition is showcased in the energy consumption, where it encapsulates water bill and electric bill objects directly. Uh, this relationship is important to calculate the total energy consumption and to evaluate their contribution score. Polymorphism is also very important in our system, and it can be seen by the recyclable item interface, where we implement specific behaviors in derived classes such as glass, paper, and plastic. This helps us accurately measure and promote our sustainability practice. And moreover, Our code also has association with the direct functionality of weekly tracking streak, interacting with recyclable items in the instances to continuously accumulate recycling data across multiple weeks. So all of this is very important in our program, and we have all of this. So we have overall our code uses oriented principles such as inheritance, polymorphism, association, and aggregation and composition, but also ensures that every design element contributes to the sustainability of the eco calculator and is consistent with sustainability goals together. These design choices empower users to effectively manage their environmental impact, analyze, and improve their lifestyle to a more greener lifestyle. So that's all for the code. I will pass on to my teammate to explain to show and to run and show the output of this code.
Now let's take a look on the output of the program. Firstly, the program will display and prompt a user to enter their user ID. Next, the user will then have to enter their name or avatar. As you can see now, the program display the welcoming message, which is welcome to the sustainability tracker. Track your recycling and energy usage and make progress in SECJ12. Nextly, the user will then have to enter the input of 3 of the recyclable items, which is glass, paper, and plastic. The user will have to enter those input for the first session and the second session. Now let's take a look on the input. Now after you have entered the number of the kilograms of each of the recyclable item for 2 of the sessions, you can see the program will then display this weekly tip. This weekly tip is actually generated randomly. It comes from this code over here. There are 6 different messages which will generate randomly for each of the week. So then the program will display whether or not you want to continue or not after it shows the weekly streak, which is the first week. So now the user will then have to input the same thing for the second week. Again, as you can see, the weekly tip over here, which is generated randomly. Now you can see that the weekly streak is 2 because the user have completed 2 of the weeks. So then the user will continue again. This program will continue until the 4th week, which is 1 month. So after the 4th week, you can see that the program will also generate random tips. But after the random tips, instead of prompting the user to continue the usage, the program will then pause and then prompts the user to enter the electric bill consumption, which is, for example, 50 and 40 for the water bill consumption. And subsequently, the program will display the total recycle score, which is 164, and the total energy score, which is 22, and then the contribution score, which is 164 minus 22. Moreover, the program will tell you whether or not you are doing a great job in responsible consumption and production. It says over here, excellent job, you are very responsible in consumption and production. Keep up the great work. As you can see from the coding, there are 3 different types of level. So if you are doing a great job, basically your contribution score will exceed 100. The program will display excellent job. You are very responsible in consumption and production. Keep up the great work. If your contribution score is over 20, it will say good effort, there's room for improvement. And if it's less, it will display needs improvement. Let's step out your game. After that, the program will then display the congratulations. Also, it will display this thing, which is you've completed 4 weeks of tracking, and then the achievement. And then the program will display the weekly streak currently, which is 4. If I were to put yes, the program will then continue until week 5, 6, and 7, and then during the week 8, the program will pause and then prompt the user to enter their electric bill, and the same thing will happen. But if I were to say no, the program will present, thank you for using the sustainability tracker, and then your avatar, and then your ID. Keep up the great work in promoting sustainability. The program also highlights error detection. For example, if we were to enter inputs that are not readable, for example here, which supposedly the user will have to enter numbers, but if user enter, for example, string or character, then the program will display invalid input, please enter a number. Some of the key features of the system that we highlighted is that the eco calculator is user friendly. The interface is easy for user to enter their input. Secondly, we also provide calculation of recycling and energy consumption, and also contribution score and ranking system. Additionally, the program also highlight weekly recycling streak tracker and also real-time feedback and motivational tips.
In conclusion, with the eco calculator, users can get real-time results on how much energy is being saved by the students and staff of Faculty of Computing, promoting ongoing environmental improvement. Incorporating technology into education, it facilitates proactive environmental decision making in line with the faculty sustainable development goals and SDG. This initiative supports a community-based approach to sustainability and encourage a greener future. Our eco-calculator shows innovations to promote sustainability by providing users with practical knowledge and promoting a culture of responsibility. We strive to not only meet but also exceed the goals of SDG 12. Let's start this journey together to a greener and more sustainable future.